Right, Year 11, I want to look at some of the work we did during the week in our last lesson. Margaret Grove, exercise 5.9. I'm not going to do any of question 6. You should be okay at drawing those and restricting the domain and finding the range. But I do want to look at question 8, sum of 9, 10, 11, and 13. Okay, so let's look at question 8. And here we're told f of x equals the absolute value of x on x. So the first thing you should say to yourself is, well, I know x cannot equal 0. But what about if x is less than 0 or x is greater than 0? So to the left and right of the y-axis. So we want to consider what happens on this side and what happens on this side. So let's put them in. Let's find f of negative x, because that's what it is. So it's the absolute value of negative x over negative x, which equals, well, x comes out of that, and you got negative x, which equals negative 1. So that means when x is to the left, y equals negative 1. What about f of x? Well, that's going to be the absolute value of x, and remember, over x. And that just means we'll get x on x, which equals 1. So that means on the right-hand side, y always equals 1. Well, let's put in the asymptote. X can't equal 0. Let's put in the point 1 and put in the point negative 1. Now we know that to the right, x always equals 1, and to the left, y always equals 1. To the left, y always equals negative 1. But we need to be careful. We need to put a circle around these to indicate that it doesn't exist there. So what does that mean? Well, it means that my domain x, well, x can be anything. X is an element of the real number system, except x cannot equal 0. And the range, or y, only equals 1 or minus 1. Y equals plus or minus 1. Now Margaret gets that wrong in the back of the book. I think it might be a typo. She says y is any real number except that y can't equal plus or minus 1, which is exactly what it does equal. Okay. Let's have a go at some of the questions from 9. So most of these you should be right. You should recognize them. You should remember them. But let's say you didn't. Let's say you're having a bit of a hard time remembering what these functions are. So let's look at the first one. F of x equals x to the 4. Well, the first thing I would do is I'd say, well, is it even or odd? Halve my work if I can. So let's find f of minus x. So that's minus x to the 4. That's minus x times minus x times minus x times minus x, which is just x to the 4. which means that f of minus x equals f of x, which means it's an even function, which halves my work because it means that I can just draw half of it in the positive side of the x-axis and then mirror image it over the y-axis into the negative side. So let's get my axes up. And now, remember, let's plot points. We'll pick some points for x and see what they equal for y. Now remember, we only have to pick positive points because we will mirror image it back. So we'll take x equals 0. Well, 0 to the power of 4 is 0. Let's take 1. Well, 1 to the power of 4 is 1. Let's take 2. 2 to the power of 4 is 16. Let's take x equals 3. 3 to the power of 4 is 81. And already these numbers are getting too large for me to fit on what I'm going to deliver as my scale for this function. So let's plot those points. Well, we've got 0 and 0. We've got 1 and 1. And there's no need to be exact here. We're just, as long as we're in the realm of reality. 2 and 16. And 3 and 81. Oh, it's way up there. So now if I join that, and I missed that last point, but I'll pretend it was there. And because it's an even function, I can just mirror this over the other side. And there is y equals x to the 4. Now, it's a parabola. Yes, it's a quartic, but it looks like a parabola. It has the same shape as a parabola, but it's a lot steeper. Now, let's look at 9c. Hey, that's the same thing, but dropped down 3 spots. So there's -3. So we just draw the graph. We'll try and draw it so that it's exactly the same. And there equals y equals x to the 4 minus 3. So I get the same curve 3 units down. Bonus points to those people who can work out here. Again, you just let y equals 0, take the 3 over, and get the 4th root of 3 and the -4th root of 3, which is 1 point something, -1 point something, I think 1.3. So 9A and 9C done. Right. Let's get rid of that and we'll move on to some of these other ones. Let's look at 9B. Now 9B, you should recognize it. You should remember it. It is a cubic and you should know what it looks like. But let's say you didn't and you forgot what it looks like. Well, let's try and see if it's odd or even. So let's find f of minus x. That's the key. Well, that's minus x cubed. Well, minus x times minus x times minus x will be minus x. So that's minus x cubed, which is minus f of x. So it's an odd function. Again, that's really cool because it means that we just have to draw half the function and rotate it about the origin. So again, I'm going to pick some points now for x and find out what happens. So let's pick 0. Well, 0 cubed, 0. Let's pick 1. when x is 1, 1 cubed is 1. We'll put the negative in front of it. Let's pick 2, negative 2 cubed, or 2 cubed is 8, so negative 8. 3, negative 3 cubed is negative 27. Or 3 cubed is 27, negative 27. Now that's enough. Let's put these points on. So we've got 0 and 0, 1 and negative 1, 2 and negative 8, and 3 and negative 27. It's not to scale, but it's going to be way down there. Join these. And then rotate it 90, rotate it up to there. Oh, the whole thing moved then. And I'll get rid of that. And there it is. And that's y equals negative x cubed. So immediately you should be able to go, wow, positive x cubed. It's going to go like that. And if you look at E, well, that's positive x cubed moved up 1. So I'll use blue this time, and I'll go up 1, and I'll draw the same thing. Moved it up 1, and if you can work out that, well, what would that be? Take the 1 over and cube root, it's negative 1, cube root, oh, negative 1. So you get E as well. All right. Not very many left to go now. Let's have a look at some of these other ones. I'm not going to do F. It's too easy. I'm not going to do D. You have to think about that. But let's have a look at G. Y equals 2 to the x plus 1. Now, let's find out what happens when I find f of negative x. I'm going to get 2 to the negative x plus 1. That doesn't look like f of x. It doesn't look like minus f of x. So it's neither odd or even. Now, people should recognize this, but let's say you didn't. It's an exponential, but let's do x and y. Let's put some values in. Let's go x equals 0. It's on my first starting point. 2 to the 0 is 1. 1 plus 1 is 2. Let's do 2 to the 1. Well, 2 to the 1, when x is 1, 2 to the 1 is 2, plus 1 is 3. Let's let x equal 2. 2 to the 2 is 4. 4 plus 1 is 5. Let's x equal 3. 2 to the 3 is 8. 8 plus 1 is 9. And we'll do one more. When x is 4, 2 to the 4 is 16, plus 1 is 17. Okay, so I've got all those positives there. Let's try some negatives. Negative 1. 2 to the negative 1, well, that's a half. And a half plus 1 is 1.5. 2 to the negative 2, well, that's a quarter. Plus 1, oh, that's 1.25. 2 to the negative 3, 2 to the negative 3, 2 to the negative 3 is an eighth. Plus 1 is 1 1/8. 2 to the negative 4 is a 16th. So plus 1 is 1 1/16. Well, that looks really interesting. That's getting closer and closer to 1 the more I move left. Well, let's see if we can draw this now. Okay. Let's plot our points. So we've got 0 and 2. We've got 1 and 3. We've got 2 and 5. We've got 3 and 9. I'm not going to put 4 and 17. It's going off the chart. I've got -1 and 1.5, -2 and 1.25, -3 and 1.125. Oh, that last one's a bit dodgy. And if I join these up, okay, there's my y equals 2 to the x plus 1. And it's going through 2, so I've got my intercept. It's all looking pretty good. But there's one thing that I need to add. And I said as it was getting closer, it's getting closer and closer to 1. So I should, I'm going to have to get rid of that big fat arrow because it's too close. It's too big. So this is an asymptote, which it approaches, but it never touches. Righto. So 8 and 9, done. Let's have a look at question 10. Now 10, it says find the domain and range and then sketch it. I reckon you're better off sketching it if you know what it looks like and then stating the domain and range. But in stating the domain and range, let's do it the way they want to do it. First of all, x minus 1 must be greater than or equal to 0 because it's the square root. So x must be greater than or equal to 1. And whatever comes out of that square root will always be positive. So y will always be greater than or equal to 0. But let's have a look at the function. We've got y equals the square root of x minus 1. Well, let's, oh my goodness. Let's, I have to erase all that. What happened then? So, pull back the original question A. So, let's go back. Y equals the square root of x minus 1. We already established the fact that x was greater than or equal to 1, and y was always going to be greater than or equal to 0. That's our domain and range, but we'll write that up a bit better next time, at the end when we write our domain and range. Let's square both sides, and we'll get y squared equals x minus 1. Add the 1 over. Y squared plus 1 equals x. Well, y equals x squared is a parabola like that. Well, x equals y squared is a parabola like that. And x equals y squared plus 1 is a parabola like that, moved 1 over. So let's draw our axes. And we know that it's a parabola on the side through 1 like that. But it only wants the positive square root. So we only want the part above. And that's what the function looks like. So now if I was to write the domain is x such that x is greater than or equal to 1, and the range is y such that y is always greater than or equal to 0. And that's at function 10. Righto. Question 11. Well, we've already seen an example of this when we did question G. So this is another exponential function, and if we just, I'm not going to look at whether it's even or odd. I'm just going to get some points. So I'm going to try x equals 0. Well, y equals 5 to the x. 5 to the 0 is 1. Let's try 1. 5 to the 1, well, that's 5. 5 to the 2, well, that's 25. 5 to the 3, that's 125. Let's do some negatives. X equals -1. Well, that's 1 over 5. 5 to the -2, it's 1 over 25. And 5 to the -3, it's 1 over 125. Okay, let's plot these. So we've got 0 and 1, 1 and 5, 2 and 25, 1 and a fifth, or -1 and a fifth, so this thing y equals 5 to the x is an exponential function, but again, I need to indicate that the x-axis is an asymptote. So finally, let's look at question 13. So question 13. First it tells me to solve 4 minus x squared. Well, as soon as you see that, you go, your beauty. This is a quadratic inequality. 4 minus x squared greater than or equal to 0. Well, that's a negative parabola because the x squared has a negative, so it's like that. And 4 minus x squared, well, that's 2 plus x, 2 minus x, difference of 2 squares, which gives me x equals -2. And x equals 2. So there are the roots. It's a negative parabola. Let's look back at this, and we want the part that's above 0. Look here, we want where the parabola is above 0. So we want x such that -2, it can equal it, and there's the solution. But then it says to find the domain and range of those. Well, let's just take this one. Y equals the square root of 4 minus x. Goodness me, this pen, it's driving me bonkers. 4 minus x squared. I'll square both sides and we get y squared equals 4 minus x squared, which is the same as x squared plus y squared equals 4. And I go, your beauty, that is a circle, and it has a radius at center 0, 0 with a radius of 2. So for the first one, for 13b number 1, says what's the range and domain of that? Well, that's only the top half of that circle. It's the top semicircle. So the domain is x between -2 and 2. And the range is y such that, well, it's the top half. So negative 0 to 2. Now number 2, well, the domain doesn't change. X such that negative 2 to 2. And the range, well, it's the bottom half of it. So it's from negative 2 to 0. And that's it. And if you're able to get to that, good on you. And I'll see you next time we have class.